Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with the same module, that is object-oriented programming module, and the same chapter, that is chapter number 3 of object-oriented, that is C++. Chapter number 3 is tokens, expressions, and the control structure. That is, what is the token and what are the various expressions and what are the various control structures like looping, switch case, if statement. So what are the various control structures that is used in the C++, right? So let's start the session. Let's start with the previous class session, what we have covered in the last class, then move to the today's session, that is the today's class. So in the last class we have started with chapter number 3, that is the tokens, expressions, and the control structures. These are the various key concepts that is available in this chapter, that is how to use or what are the content that is defined in this chapter, right? We have started with some just an introduction. That is, what is the introduction? That is, C++ is a superset of C language. That is, it is an addition of the C language, and therefore most of the construct, most of the tools, most of the algorithms that is available in C language must be available in the C++. However, there are some exceptions and additions. That is, there are some additions in the C++ as compared to the C language. Then we have talked about the tokens. Tokens are the smallest units, that is the smallest individual units in a program. So whenever we say or whenever we add any smallest individual unit in a program, that is known as the tokens. The tokens may include the keywords, identifiers, constant, string, operator. So these are known as tokens. So any smallest individual unit that perform the operations in the programming language, that is known as the tokens, right? For example, the tokens includes the or token includes the keyword, identifier, constant, string, operator. So these are the various tokens. Then we talked about the what is the keyword. So we have talked about all these terms in detail. That is, what is a keyword? That is a term that is used for defining something and that reserves a space in the memory. That is, keywords are the predefined or the prefix words that is used with the various variables, like int. Int is also a keyword that is used with defining the variables. That is a feature of the C++. So keywords are the various or one of the important features that is available in the C++ and the C both, right? Then we are talking about the identifiers and the constraints. Now the next question is, what is the identifier? That refers to the name of the variable, function, array, classes, etc. that is created by the programmer. So whenever we create any or whenever we define any variable, we create any variable, we create any array, classes that is created by the programmer, that is created by the developer, that is known as the identifier. For example, if I've created one if I've created one variable, that is int a, then a is known as the identifier, right? And each language has its own rule for naming these identifiers. Now what are the rules that is used for the for defining the identifier, for defining the variable name, for defining the array in the C++? These are the rules that is common to the C++ and the C language. We have studied already what is C language. Now next is what are the rules that is available in the C++? The first rule is only alphabetic characters, digits, and underscores are permitted. That is, in the name of the variable, only the alphabetic characters from A to Z, numbers, that is the digits 0 to 9, and the underscores are permitted. Second point says the name cannot start with a digit. This is a mandatory condition, that the name cannot start with a digit. And uppercase letter and the lowercase letters are distinct. That is, they are different. For example, if I want to define the class of the C, that is the first character of the class, that is the class of the C, is in small letter, not in capital letter. So there is a difference between the uppercase and the lowercase letter. So C++ is a case sensitive language. Then a declared keyword cannot be used as a variable name. So these are the various keywords that is used. This the ASM, auto, break, double, enum. These are the various keywords. A major difference between C and the C++ is the limit on the length of the name. In C there is a limit, that is or the variable name is of 32 characters at the most, that is maximum it contains 32 characters. But in C++ there is no limit on the number of characters. We can define variable of n number of or any number of characters. Constraint that refers to the fixed value that do not change during the execution of the program. For example, if I declare the constant int a equals to 10, then the a value, that is 10, it is declared as a constant. It does not change, or it will not change during the execution of the program, so it remains the fixed. So constant refers to the fixed values that do not change during the execution of a program. C++ also recognizes all the backslash or backslash character constant available in C. Then we have studied about the basic data type, that is what are the basic data types. So C++ data types is divided into three parts. One is the C++ user defined type, that is the user defined means that is defined by the user. Then built-in type, that is already built. Then derived type, that is derived from another data type, that is known as the derived type. So first one is user defined type, that is means that is created by the user. For example, structure, for example, union, for example, class, for example, enumeration. So these are the user defined data types that is available in the C++. Then built-in data type, that is the int, char, float, double. So these are the built-in data type. Then derived data type, that is derived from another data type, for example, array, function, pointer, reference. These are the derived data type that is available in the C++. Built-in, int, void, float, double, these are the int. Char is also int. Then we have studied about these terms, that is what is a pointer. Then what are the user defined data type, that is what is the user defined, for example, arrays, for example, class, for example, array, for example, class. These are known as user defined data type. This is structure, union, class, enum. So first of all, there is a structure and the classes. So we have studied about the structure and union in the C language, and there is a new concept, that is a user defined data type, that is a class. We have studied in the second chapter in the last class what is a class. So it contains, or it compromises, or it contains data members as well as the functions. So class structure we have defined. First of all, there is a data member, then there is a member functions, right? That may be used as a public, protected, or private. That is it is used in a protected mode, public mode, or the private mode. Then enum data type, that is also a user defined data type. We have studied that if whenever we define the enum data type, that's variable name are given some values. That is, for example, we have declared 4 variables. The first variable is contained or is getting the value 0. Second variable getting the value 1. Third variable or second variable getting the value 3, and so on. So enum contains, or enum keyword automatically enumerates a list of words by assigning them the value from 0 to 1, 2, and so on till the number of variable it is used. That is your enum data types. Then derived data type, that is derived from another data type, that is known as the derived data type. For example, arrays, for example, pointer, for example, reference, that is known as the derived data type. What is array? That is a collection of homogeneous data types that are stored in one array, that are stored at one location, that is known as array. And the array always starts from the 0. Then functions, that is also a user derived data type that has a various pointer, that has a various variable that makes the program very easy. Then pointers, that points to some other variable that stores the address of some other variable. Then symbolic constant, what are the symbolic constant, how to create, or what are the ways to create the symbolic constant. First of all, using the qualifier constant. Second, defining a set of integer constant using enum keywords. Then we have studied in the last class also, that is what is the type compatibility, that is how different types, how different data types are compatible with each other. That is your time or the type compatibility. For example, if I have declared the any variable as an int, then how it is used as a float, or how it is used as a double, or how it is used as char. So how one data type is converted into another data type, or how one data type is compatible with another data type, that is a type compatibility, right? Then then we have also discussed that is how to declare the variable in the same way that we have declared the variable in C. In the same way the variables are declared in C++. Yeah, this is one of the important points that we have discussed. The C++ allows the declaration of a variable anywhere in the scope. That means we will declare, or we would declare any the variables, or at any place. That is, there is no foundation that it is declared in this scope, in this place. No, there is no limit, there is no foundation. But C++ allows the declaration of a variable anywhere in the scope. This is the example that we have discussed. This is the declaration part. This is also declaration. This is also declaration. Then we have studied about the dynamic initialization of the variable. That is, dynamic initialization means initialize the variables at the dynamic time. What is the dynamic time? That is the compilation time. So in C, the variables can be initialized using the constant expression, and the C compiler will fix the initialization at the time of compilation. C++ permits the initialization of the variable at the runtime. That is, while the program is executing, at that time also the variable will declare, that is known, or variable will initialize, that is known as the dynamic initialization. In C++, a variable can be initialized at runtime using expressions at the time of declaration. Then next is a reference variable. We have discussed that is what is the reference variable. So whenever we give the alias name, that is whenever we want to give the alternative name to any variable, that is, for example, if I want to change my variable, that is A to Z. Now if I want to refer the Z or J, so it gets the value of the A. So reference variable means getting the alias name or getting the alternative name for the variable. For example, if we make the variable sum a reference to the variable total, then the sum and the total can be used interchangeably. That is, if I use, or if I make the variable sum as a reference to the variable total, that means the total value, or the total output, or the total anything that is related to the total is going to the sum. So now sum and total are the interchangeable. That is, we can interchange the values, we can interchange the content between the sum and the total. Reference variable is created as follows. This is the type, that is how it is used. First of all, there is a data type, that is, for example, int float, that is a data type. Then there is a ampersand sign. Then there is a reference name, that is the alias name, and there is a variable name. That name will be changed, that is a variable name. Alias name means, reference name means the new name. This is what is known as. Then we have discussed what are the various operators in C++, that is different operator that is defined in C++. So these are the various operators, and two major operators that we have studied in the chapter number 2 is the insertion operator and the extraction operator. One is insertion operator, one is extraction operator. Insertion operator is used to display anything on the screen, that is the insertion operator. Extraction operator means getting something into the memory, that is reading the data into the memory, that is known as extraction operator. And these are the this is known as the insertion, this is known as the extraction. Then first one is other new operators are scope resolution operator, then pointer to member declarator, then pointer to member operator, then pointer to member operator, this is also, then delete. This is also operator that releases the memory. That means, for example, if a variable is created to get the memory, if I want to release the memory, that is releasing the memory means emptying the memory, that is done by the delete. In C, we use the malloc and the calloc function for dynamically allocating the memory and deallocate the memory, a calloc function. In C++, the new and the delete is used. The new is used to automatically getting the memory, that is automatically allocating the memory, and delete is used to deallocate the memory, that is deleting the memory. So this is these are the operators. One is endl, that is a line feed operator, new, that is a memory allocation operator, then setw for getting the field width operator, that is changing or getting the changes in the structure of the operator. In addition, C++ also allows to provide new definition to some of the built-in operators. That is, we can give several meaning to an operator depending upon the type of the arguments used. This process is known as the operator overloading. Then next is what we have studied is the scope resolution operator, that is used in case of the global and the local variable. So whenever anyone who wants to access the global variable, that can be accessed by using the scope resolution operator in any block. That is, if I've defined the one operator or one variable as a global variable, for example, int a equals to 10, that is a global variable, for example. Now, if I want to use the global variable in the internal level, that is the internal scope, that is the internal block, so it is also possible to use or to get the global variable with the use of scope resolution operator. This is the example of the scope resolution operator. What is the symbol of scope resolution? This is the symbol. Four dots are the symbol of the scope resolution operator. This is the example that we have discussed. This is the global variable that is used. This is the local variable, and this is the operation on the global and the local variable. So it is used the global variable whenever it is used with the scope resolution operator. Then we have discussed also the member differencing operators. These are the operator that is used with the pointers to declare the pointer, to declare or to access the pointer, to access the member with the pointer, with the variable, with the object. Then we have also discussed about the memory management operators. As we have studied, there are two operators, one is new, one is delete. New is used, or new operator is used to allocate the memory. In the same way, free is used to deallocate the memory. Sorry, delete is used to deallocate the memory. So two operators are used, one is the new, one is the delete. Then we will discuss also about the manipulators that are used to format the data. So suppose I want to give the, or suppose I want to format the data. That is, a data is given, I want to format. That is aligning the data to the right. Give a space between two words. That means the formatting of the data. So that are used to format the data. That is known as the manipulators. The most commonly manipulators are NW and the setW, that is used for the lining or for giving the width, that is done by the setW, and NL means provide the line between the end of the line, that is append the line at the end of the line. That is the NL operator or NL manipulators. Then we have discussed about the typecast operator. That is typecast means whenever there is a conversion of the variable, that means the int is changed into the char is changed into the float. That is changing from one data type into another data type. That is done by the typecast operators. Then expressions and their types. This is the today's topic. So let's start the today's topic. Let's start the today's session. The next is, that is the today's topic, is expressions and their types. That is, what are the expressions and what are their types. This is, an expression is a combination of operators, constant and variables that are arranged as per the rules of the language. So what is an expression? That is simply a combination of operators, constants and variable. So for example, if I use plus minus constant a and the variable bw, that means that is an expression. So if I combine the operators, if I combine the constant, if I combine the variable that are arranged as per the rules of the language, that is known as the expression. It may also include function calls which return values. An expression may consist of one or more operands, zero or more operators to produce a value. That is, expression can contain the values, operators, operands to produce a value. Expression can be of or may be of the following 7 types. So these are the various types of the expression that is used. One is known as the constant expressions, then integral, that is the integer expressions, then float expressions, then pointer expressions, then relational expressions, then logical expressions, and bitwise expressions. So these are the various expressions that is given in C++, and there are different types of these expressions, and the most commonly expression is the integer expression and the pointer expression, that is the pointer operator or the pointer expressions. An expression may also use combination of the above expression, that is we can combine the various expressions, that is in a programming it is also used that there is a combination of various expressions, that is constant and the integral expression, that is constant is also used with the integer part, that is a10, that is also expression because it is a combination of operators, constant, variables. So whenever we combine multiple expressions, that expression is known as the compound expression. Compound means combination of various expressions. So let's start with the constant expression. That means constant expression consisting of only the constant values. Any constant value that is given, that is available, that is known as the constant expressions. This is the constant expression example, that is 15, 20 plus 5x. These are known as constant expressions. Then integral expression, that is the integer expressions. So whenever we use the variables that gives the integer, that provides the integer value, that is means a discrete value, that is known as the integral expressions. So integral expressions are those which produce integer results after implementing all the automatic and explicit type conversion. This is the example m into n minus 5. These are the various integer expressions. Then float expressions that give some decimal value, float value, that is known as the float expressions. Then pointer expressions that it gives the some address value, that is known as the pointer expressions. Then relational expressions, that means that gives some boolean value, that is 0 and 1, that is known as the relational expressions. Then logical expressions. So whenever we use the logical operators like and, or, these are the logical operators. So whenever we use the logical operators, that is known as the logical expressions. So for example, this is the example. First of all, checking whether a is greater than b and x is equals to 10. That means if has a value 10, and if a is more than the b, that is a is more than the b value, that is the logical expression. If both the conditions are true, then only the output is true. And then there is a OR operator, that is x equals to 10 and the y equals to 5, that is x has the value 10 and the y has the value 5, and there is a OR, that is either x has a value 10, either y has a value 5. In both of these scenarios, if any of the condition is true, then the output is true. That is a logical expression. Then bitwise expression, that means shifting the bit, using the bit at one time, that is known as the bitwise expressions. Then next is special assignment expression, that is special assignment means assigning the value in a special way, that is a compound or the chained assignment, that is one value is assigned to another, and then another value is also assigned to another part, that is one value becomes a value of the another, that is 1 into 1. This is example, x equals to y equals to 10, that is first 10 is assigned to a y and then to the x. So first of all this is used and then this is assigned to the y. Then embedded expression, that is a embed the assignment, that is embedded expression, not this is embedded assignment, that is embed the assignment, embed the value inside other expression, that is y equals to 50. This is the embedded assignment, that is assign the value of 50 into the y and then plus 10 and gives the output into the, or gives the value into the x. Then compound assignment, that means combination of the assignment operator with the binary arithmetic operator, and this is one of the important assignment that is used in C++. For example, x equals to x plus 10. That means initialize, or that means adding the values of x to the 10. Suppose the x has a value 1. Now the x value become 11. Why? Because the 10 is added to the x. So that is x equals to x plus 10. That may be written as x plus equals to 10. Then implicit conversions, that is how to use the implicit conversions. That is how to convert from one data type to another data type. This is the example, this is the diagram that shows there are multiple integers like unsigned int, signed int, long int, float, double, long double. That is a waterfall model of the time conversions. Then operator overloading, that means assigning the different values. That means um, use the same operator with many operands. That is, for example, if plus is used with many operands, that is known as the operator overloading. The condition is that it is used in same expression in the same statement more than one time. That is known as the operator overloading. Hello, 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 hello. Yeah, are you able to hear me? Okay, so I'm so sorry for the delay. There is some technical problem. There is some low bandwidth. So let's continue. Next is your operator overloading. That is how to overload the operators. For example, the same operator plus is used with two operands. Whenever we use the plus with the characters, that means concatenation. If I want to add two strings, for example, Harry, Larry, I want to string the two strings, that is Harry and the Larry. If I want to add them, that is also done by the plus operator, that is the plus sign. In the same way, if I want to add two numbers, for example 5 plus 7, that gives the 12, that is also used by the plus operator, that is also used by the addition. So that is also used, means the plus operator is used with the characters also, string also. In the same way, the plus operator, that is a arithmetic, that is a addition operator, is also used for the characters. That means the operator overloading. That is, at the same time it is used for the character addition, character merging, character concatenation. In the same way, at the same time it is used for the number addition, that is a 12. So this is Cout 75.86. This is well done. That is addition of the well plus done. That is a well done. Right. Yeah, this is the most important point. These are the various operators that cannot be overloaded. One is the member access operator. This is the one operator. Next is conditional operator. This cannot be overloaded. And one is scope resolution operator. One is the size of operator. So four operators that cannot be overloaded. What are the four operators? One is the size of operator. One is the member access operator. That is the dot operator. One is the conditional operator. That is a question mark operator. One is the scope resolution operator. That is the four dots operator. One is the size of operator. So these are the four operators that cannot be overloaded. Next is operator precedence, that is which operator to be used one, that is the precedence of the operator. These are the various operators and their associativity. That means how it works from the left to the right, right to the left, that is how it works. Then this is the most important, that is the control structures. In the same way what we have studied in the C language, various looping, various content that comes under the control structure. In the same way there is a control structure in the C++ also. In C++ a large number of functions are used that pass the messages and process the data that is contained in the object. A function is set up to perform a task. That is, in C or the C++, the same program or the huge program or the big program is divided into various functions. So in C++ also, that is divided into various objects, that is divided into various functions, and the variable that is known as the object in C++ is able to communicate with various data and process the data that is contained in the objects. A function is also set up to perform a task. When the task is complex, many different algorithms can be designed to achieve the same goal. Some are simple to comprehend while others are not. Experience have also shown that the number of bugs that occur is related to the format of the program. The format should be such that it is easy to trace the flow of execution of statements. Now, one method of achieving the objective of an accurate, accurate means the correct result without error, that is error resistant and maintainable code, that is maintain the code in terms of money, in terms of resources, so that it is used in a combination of three control structures. So there are three control structures in C++. One is the sequence structure, that is a straight line. One is the selection structure, that is a branching, that is a looping, or that is a statements. Next is the loop structure, that is the iteration or the repetition. So control structure is divided into three parts. One is the sequence structure, one is the selection structure, one is the loop structure. So these are the three structures, these are the three control structure that is used in the C++. So these are the various structure. This is a sequence, that is entry, action 1, action 2, action 3, that is contained in a sequence. Selection means there are two choices. If the condition is true, either opt for the true, then if the condition is false, then either opt for the false. Then in looping, there are multiple looping, that is the same task is assigned or the same iteration is doing more than one time, that is a loop. So these are the three types. One is the selection, one is the sequence, one is the looping. Like C, C++ also supports three basic controls structure, that is the sequence, selection and the looping, and implement them using various control structures. This shows that C++ combines the power of structured programming with the object-oriented with the object-oriented parameters or the object-oriented contents or the features. So first of all, there is a if statement, that is a sequence statement, that is a if statement. One is, there are two parts. One is a simple if, one is the if else statement. This is the simple if, that is the first level. So this is the control structure. One is selection, one is sequence, one is looping. Selection is also divided into two parts. One is the if else, one is the switch. That means selection, how to select the data by using the switch case, by using the if else statement. And whenever we use the sequence, there is no criteria, there is no part of the sequence. And looping means there are two types of looping. One is the do while loop, one is the while loop. So the first form of if else is if the expression is true, that is the condition is true, statement is true, or if the condition is true, then the action 1 will perform. Otherwise action 2 is performed, action 3 is performed. This is the else part. If the expression is true, action 1. If else means if the expression is false, that is instead of true it is false, then action 2. So this is the form 1, this is the form 2. One is without else, one is with else. Then next is the switch statement, that is if I want to choose an option from large number of options. Suppose if there are 4 options and I want to select only one option, that is done by the switch case, that is a switch statement. This is a multiple branching statement where based on a condition the control is transferred to one of the possible points. That is, there are a large number of possible points, but we have to select only one point. So the control is transferred to one of the many possible points, one of the large number of points, that is done by the control, or that is done by the switch statement. This is the syntax as simple as we have studied in the C language. Switch expression, that is a switch condition, that is expression, then case 1, that action 1, then case 2, then action 2, that means the statement, case 3, action 3, and at last if from among the cases if there is some another case, so that is a default case, then there is a action 4. Then next is do while statement. So while is a entry control loop. Why? Because the expression is checked at the time of the entry. So the time we enter into the loop, the expression is checked, that is a while loop. And the time we exit the loop, that is done by the do while, or whenever the condition is checked at the exit of the time, that is done by the do while. That is known as the exit control loop. This is the main difference. One is the entry control loop, one is the exit control loop. Entry means because the condition is checked at the time of the entry, and exit control loop means the condition is checked at the time of exit of the program. That is the exit control loop. So this is known as exit control loop. Based on a condition, the control is transferred back to a particular point in the region. What is the syntax? This is do, this is action 1. That means do while is the while the condition is true. That means the while the expression is true, that is the condition is checked at the time of exit of a program. That is do. First of all, action 1, that means the first statement will execute. Then while, that means the while the condition is true, that means the condition is checked at the time of entry of exit of a program. Then while, it is known as entry control loop. Why? Because this is the syntax. While condition is true, action 1, then action 2. Then for statement, that is the entry control loop, and used when action is repeated for a predetermined number of times. That is a for statement. This is the syntax. For initial value, that is the first value, that means initializing the values. Then there is a test, that means checking the condition, that there is a increment or decrement, depends on the value, depend on the expression, that is either increment or decrement. The syntax of the control structure in C is very similar to that of C++ is very similar to that of C. That means every control structure that is used, either that may be a sequence, either that may be a selection, either that may be an iteration. Any control structure that is used in C++ is almost very similar to the statement, or very similar to the structure that is used in the C. And therefore they are implemented as and when they are required. For example, if there is a usage of if there is a necessity that in a one line we have to divide, or in a one line we have to declare the variable, expression, condition, increment or decrement, that can be done by using the for loop. In the same way, with the use of while loop, whenever there is a requirement of checking the condition at the time of entry, that is done by the while loop. This is the summary. So first point, it says C++ provides various types of token that includes the keywords, identifier, constant, strings and the operators. Now what is identifier? So this is just crux of the chapter, so that these are the basic points, so that you have to remember these basic points if in detail you are not clear, or you are not clear with the concept in detail. So please focus on these basic concepts, these basic points also. Second point says identifier refers to the name of the variables, functions, arrays, classes, etc. That is, it contains, or identifier means to identify something, whether it may be a variable, whether it may be a function, whether it may be an array, whether it may be a class. So that refers to the name of the variables, function, arrays, classes, etc. That means add on anything that can be done. Then next point says C++ provides an additional use of void for declaration of generic pointers. Then next point says the enumerators is also used, that is used to define the value with the variable, that is define the value to the names of the variable, that is done by the enum. Then next point is in C++ the size of character array should be one larger than the number of characters in the string. That means the string always terminate with the null character. That means the size of the character array should be one larger than the number of characters used in the string, because it starts with the 0 and ending with the last one. For example, if there are 7, there is an array of 7, that means it starts with the 0 and ending with the 6. That means total of 7 characters. Then next point says C++ adds the concept of constant pointer and the pointer to constant. Then pointers are widely used in C++ for memory management and to achieve the polymorphism. That is in detail we have to discuss in chapter number 8. That is the polymorphism. So pointers are generally used in C++ for memory management, that is usage of the new and the delete, that is the allocating the memory and deallocating the memory, and also used for the polymorphism. Next point says C++ provides a qualifier known as the constant to declare name constant which are just like the variable except their values cannot be changed. A constant modifier defaults to an int. The next point says C++ is very strict regarding type checking of the variable. It does not allow to equate variables of two different data types. The only way to break the rule is typecasting. Then next point is C++ allows us to use or declare a variable anywhere in the program, as also its initialization at the runtime. That is, we can declare the variable at the runtime also in the C++. Then next point says a reference variable provides an alternative name for a previously defined variable. That is, if I use the reference variable that gives the alias name or that gives the replacement name for the variable, that means give an alternative name for a previously defined variable. Both the variable refers to the same data objects in the memory. Then next point says a reference variable must be initialized at the time of the declaration. Then a major application of the scope resolution operator in the classes is to identify the class to which a member function belongs. So one of the major role of scope resolution operator is that it is used to identify the class to which class a function belongs to. Suppose there are 4 classes that is defined. For example, there are one member function that is a display. So display is related to which class, that is identified, or that is done by using the scope resolution operator. Then next point says in addition to the malloc and the calloc and the free function that is used in the C language, that is malloc and calloc is used for allocating and free is used for deallocating. In the same way, C++ also provides two functions, two operators, that is the new and the delete. New is used for allocating the memory and delete is used to deallocating the memory, that is allocating and freeing the memory in a better and the easiest way. Then next is C++ also provides manipulators to format the data display. That is, C++ also provides the manipulator, that is how to manipulate the data or how to format the data that is available in C++. The most commonly used manipulators are NW or ZW and the NL. Then next one is C++ also supports 7 types of expressions like integer expressions, control expressions, character expressions. So there are various expressions that is available. There are total of 7 expressions that is available in C++. C++ also permits explicit type conversion of variable and expressions using the typecast operators. Like C also supports 3 basic control structures like namely sequence, selection and the looping. So there are 3 control structures, one is sequence, one is selection, one is the looping, and implement them using various control structures such as if else switch, do while and for. So these are the various control statements that is used in the C++. These are the key terms, various key terms. These are the various questions that is used that you have to study. Now next is functions in C++. That is what is the functions in C++. In the same way we have studied in C, there are various functions. In the same way there is various function in the C++ also. So first of all, let's take a break, then move to this chapter, that is chapter number 4. What are the various functions, or what are the functions, or what is the meaning of functions in C++. So let's take a break right now, then move to this chapter, that is the chapter number 4. So let's take a break. So come back from the break. Now let's start the session again after the break. So let's start with the chapter number 4, that is functions in C++. That is, what are the functions, or what are the various functions, or what is the function in C++. It's the same function that is very similar to the C. That is, that are the various subparts of a program. That is, whenever we divide the main program into various parts, that is known as the functions in C++ or a function in C++. So let's start what is the function in C++. This is the chapter, and these are the various key concepts for the C++ functions. This is the introduction to the function, that is what is a function, how to use the functions. So we know that functions plays an important role in C development or C program development. That is, we already know dividing a program into various functions into various parts is one of the major principle of top-down, structure-down or structured programming. That is the it is one of the major term, that is dividing the main program into various functions. It is one of the principles of the top-down structured programming. Another advantage of using the function is that it is possible to reduce the size of the program. That is, whenever we use the functions, it is also advisable, or it is also beneficial to use the functions as dividing the main programs into, or reducing the size of our programs by calling and using them at various places. So whenever we divide the main program into sub-programs, into sub-parts, that is used by the different organizations, that is used by the different developers at various places, that is, it is used at different places in a program. Recall that we have used a syntax that is similar to the following in C program. This is the function declaration, that is declaring the function, that is a void show. So whenever there is a semicolon, that means the function declaration. Now this is the main function, that is a function calling. So this is, first of all, the function will be declared, that is the function declaration. Then there is a main function, that is the entry of the main gate, like that is a main function. Then show function, this is known as the function calling. So whenever whenever the developer have to call the function, that is done by the giving the parenthesis. In the parenthesis, if there are number of arguments, then we can give the arguments, otherwise it is blank, that means a void. Then there is a semicolon and there is a closing of the main function, that is the main function, then show function, then closing of the main function, that is a function call. Then next is void show, that is a function definition, that is the definition of the function, or what does it contain in the function, that is a function definition, that is a void show. Function definition, these are the various function body, that is what is the body of the function. Then this is when the function is called, the control is transferred to the first statement in the function body. So when the function is called, the control is transferred to the first statement, to the first place in the function body. The other statement in the function body are then executed and control returns to the main program when the closing brace is encountered. So whenever the function is used, whenever the function other statement in the body functions are executed, the control is transferred, the control returns to the main program. For example, if the function definition gives the output is returned to the main function, that is, it returned to the main program when closing braces are encountered. Right? C++ is no exception. That is, function continues to be the building blocks of C++ program. In fact, C++ have added many new functions of new features to the function to make them reliable, or to make them more usable and flexible to use. Like C++ operator, C++ function can be overloaded. So we can overload the functions that is used in the C++ in the same way which we overload the operators. First of all, the main is the main function. That is, the main function means the void main that we have used in the C, C++, that is the main function. So C does not specify any return type. As we have discussed in the last class also, that the C does not specify any return type. That's why in most of the cases we use the void main. That means there is no returning part of the main function, which is the starting part, or which is the starting point of the execution of the program. This is just example, that is a definition would look like this one. That is a main function, then main program statement. That is the main function, then the main program statements. This is perfectly valid because the main function in C does not return any values. Why? Because it is a rule of the structured programming, so that whenever we use the main function, it does not return anything or any value. So this is perfectly valid because there is no return type before of the main function. There is no int, there is no char, but this is blank, that means a void. That means there is no return type of the main function. In C++, the main returns a value of the type int to the operating system. C++ therefore explicitly defines main as a matching one of the following prototypes. That is, main function is also used in C++ to return the values. For example, int main. So whenever we use the int main, so there is a return 0. That means it returns something. So that is a return 0. So there is a int main. Then next part is int main, int argc, char pointer argv. So there are two expressions, there are two values, there are two variable that is used. One is the argc, one is the argv, and argv here is of array type, that is for char pointer argv. The functions that have a return value should use the return statement. So whenever we use main, that is the int main, so it uses a return statement. It have a return statement for termination. The main function in C++ is therefore defined as follows. So this is the main function that is defined. There is a int main, then there is a return 0. So why it is return 0? Because it is returning something. That's why it returns the 0. That is a return 0. But in C it is not returning anything. So there is no boundation, or there is no requirement of the returning the 0. So whenever the main function return anything, or whenever any function return anything, so there is a mandatory condition to write down the return in the at the closing of the function. Since the return type of function is int by default, the keyword int in the main header is optional. Most C++ compiler will generate an error if there is no return statement. If we are using the int main, and if we are not using the return at the end, so most of the compiler, or most means 99% compiler, generates an error or warning if there is no return statement. Turbo C++ issues the warning that the function should return a value. So this gives the warning that is a Turbo C++ is one of the compiler that is used for the C and the C++ both. So that gives an error, that gives an warning that function should have a, or should return a value whenever we use any int main or void main. Sorry. Whenever we use the int main, so if we are not using the return, so that gives an warning or the error. And then proceed to compile the program. So it is good programming practice to actually return a value from the main. Then next is function prototype. Now what is function prototype? In simple terms, function prototype means defining the type as well as the number of arguments. That is the in parenthesis we define the int, we define the float, that is the type as well as the number of argument, that is known as the function prototype. So prototype means that is available in the parenthesis, that is what type of numbers, what type of members, what type of data type, what type of variables. That is, for example, int a, int b, that is two variables are of int type, that is a prototype. That means it specifies a number and the type of argument that is used in a function. In simple terms, I am repeating again, it defines or it specifies the number and the types of the argument that is used in a function. That is the prototyping, that is the function prototyping. So function prototyping is one of the major improvement that is added to the C++ function. It is not used in C function, but it is used in the C++ functions. The prototype defines a function or describes the function interface to the compiler by giving the details. What type of details? That is the number and the types of argument and the type of return type. This is the prototype. That means the number of arguments, types of arguments, as well as the types of return value. That is a prototype. With function prototyping, a template is always used when declaring and defining a function. When a function is called, the compiler uses the template to ensure that proper arguments are passed and the return value is treated correctly. This is the function prototype. This is one of the syntax. That is a type. That means the type means data type. Then there is a function name. There is a argument list. Argument list means the number and the type of arguments. That is a prototype means number, type of arguments, as well as the return type. So this is the syntax. That is a type. Then there is a function name. Then there is an argument list. The argument list contains the types and the number of arguments, as we have, or as I told you. This is one of the example. One of the example is float. Then there is a volume. Then int x, float y, float z. That means float x, float y, int x, float y, float z are the types and the number of arguments. That type means it is of x is of int, float y is of float, z is of float, and the number is 3 and the type is int float float. Note that each argument variable must be declared independently inside the parentheses. That is, a combined declaration look like this one. Float volume, int x, float y, z. That is, y and z are both of float values. That is illegal. So we cannot define that float y comma z because or the compiler cannot predict what is the data type of the z. It cannot predict. So it is mandatory to give the or specify the data type along with the variable name. So this is not illegal or this is not valid whenever we use like this one, float y comma z. In a function declaration, the name of the arguments are dummy variables and therefore they are optional. So this is also optional that give the name of the argument in case of function declaration. So when I declare the function, it is not mandatory to give the name of the variables. No, but we have to specify the type. For example, if I have to declare the variable, 3 variable, so we have to specify the int float float, not giving the name like x, y, z. No, there is no mandatory, there is no foundation, but only giving the type, that is float or int float float. That is acceptable at the time of declaration. At this stage, compiler only checks for the type of arguments when the function is called. In general, we can either include or exclude the variable names in the argument list of prototypes. In a function definition, the names are required because the argument must be referenced inside the function. So whenever there is a function definition, the names are required or the names are used because the argument must be referenced inside a function. This is one of the example. That is a float volume, int a, float b, float c. So these are the three values, or these are the three variables that is used. One is int a, one is the float b, one is the float c. The function volume can be invoked in a program as follows, like this one. This is the function calling, that is float cube, that is the output of this function, that is the volume, that has 3 data type, that are 3 variable like b1, w1, h1, that is the breadth, width and the height. So these 3 values must be declared, then the output of this volume function is going to or is stored in the cube 1, that is of type float. We can also declare a function with an empty argument list, like this one, void display. In C++, this means that the function does not pass any parameters. It is identical to the statement like this one. There is no foundation that it is used void. If there is a blank parenthesis, that means there is no, or there are no number, or there are no argument that is used in the functions. However, in C, an empty parenthesis implies any number of arguments. So it is different in C and the C++. If I am giving the empty parenthesis, that is a blank parenthesis, C think that, or C assumes that there are, or implies that there are any number of arguments, that is a n number of arguments. That is, we have foregone prototyping. But in a C++ function that have an open parameter list by the use of elifs in the prototype as shown below, like this one. Now next is call by value and call by reference. It is one of the important concepts that we have studied in detail in C. Remember, now what is anyone can tell me the most of the persons available is Larry, Joseph and Lisonga. And anyone can tell me what is the difference between call by value and call by reference in C language, not in C++. This is exactly the same, but I want answer from the student, so that I want to know whether I teach very well or not, so that students will of the things will clarify the concept or not. So anyone, what is the difference between call by value and call by reference? Anyone can tell me? Yeah, everyone, are you able to hear me? I'm talking about, tell me anyone, What is the difference between call by value and call by reference? Remember, we have discussed in C, whenever there is, or when there is a swap function, remember whenever there is a swapping of the two values, so when we pass the values, that is a call by value. When we pass the address, that is called by reference. So remember and tell me the answer. No one. This is not correct, students. All right. Yeah, call by value means passing the value direct. That is the Joseph answer. Straight. Yeah, that is correct, but not exactly correct. Anything else? Anyways, I will tell you. Call by value means passing the values, not the reference. So whenever we declare the function, that arguments are known as actual arguments. And whenever we define the function, that is give the definition of the function, that is known as call by reference. That is known as the formal argument. So one is known as the actual argument when it is used with the when it is used with the function declaration, and one is actual argument when it is used with the call by, when it is used with the function definition. So there are two arguments, one is actual, one is formal. Actual means along with the function declaration, formal means along with the function definition, right? So there are two functions, call by value and call by reference. So when we use the call by reference, the actual argument or formal argument, if there is any changes in the formal argument, that does not impact on the actual arguments. I'm repeating again. If there is any change in the formal arguments, that does not impact on the actual arguments. That means if there is any changes, if there is a swapping of the value, if there is an addition of the values, that changes must be only for that block only. That is till the time curly brace is there, that is available in that block only. That does not make the impact on the actual arguments. That is called by value, because everything is available on the value. So there is no criteria that the values are permanent. No, values are changes during the execution of the program. So the values does not change. So in call by value, whenever there is any changes in the formal argument, that does not make impact on the actual arguments. But when we use the call by reference, that means instead of passing the values, we are passing the addresses. Now every operation is performing on the addresses. So in call by reference, if there is any changes in the formal arguments, in the formal definition, that is in the function definition, if there is any changes, that changes becomes permanent. That is, the changes become permanent means why their changes become permanent? Because everything is available on the address. So if there is any change in the address, if there is any change in the address of the variable in memory, so that is permanent. So in call by value, if there is any change, that is a permanent, that is visible to the actual arguments also. But in call by value, if there is any change, if there is any data or change in the formal argument, that does not impact on the actual argument. This is the main difference between the call by value and the call by reference, right? This is the same example. This is the example of the reference. How do I know this is the example of reference? Because of this one. This is ampersand. That means passing the address of the A, passing the address of the B. That means these are known as the reference variables. This is int t. That is a new variable. That is A. That is dynamic initialization. That is a swapping of the value. This is a function definition. Now next is return by reference. That is this is also possible to return the reference, that is return the address of the address of the variable. Then next, one of the important concept is inline function. That is, what is the inline function? So one of the objective of using functions in a program is to save some memory space. So one of the major advantage or one of the major objective of using functions, that is one of the major advantage we can say of using the function, is to save the memory space, because the program is divided into multiple parts, so it saves the memory space, which becomes appreciable when the function is likely to be called many times. Why? Because the same program or the same function will be called at n number of programs, n number of variables. So one of the objective of using functions in a program is to save some memory space, which becomes appreciable when a function is likely to be called many times. However, every time a function is called, it takes a lot of extra time in executing a series of instructions for tasks such as jumping to the functions, saving registers, pushing arguments into the stack, and returning to the calling function. When a function is small, a substantial percentage of execution time may be spent in such overheads. So whenever the function is small, so if we declare the function, we define the function in a small quantity, then the percentage of the time that is used for execution may be spent in overheads that is available, like executing the instructions, jumping from one part to another. So all these are the various expressions, all these are the various tasks, that is all these are the various overhead that is available in executing the program. So one solution of this program is to use macro definition, properly used as known as the macros. Preprocessor macros are popular in C. As we have studied in C, as we have studied in Excel also, what is a macro that is used for the recording purpose. So macros are also used in the C. But major drawback is that they are not really function. Therefore, the error checking does not occur during compilation. That is, the error checking is difficult during the compilation whenever we use the macros in the C. So that is a major drawback, that is a major limitation for the macro that is used in the C language. C++ have a different solution to this problem. That is, to remove the overhead, C++ have a solution. To eliminate the cost of calls to small functions, C++ introduces or provides a new feature that is known as the inline function. So inline function is a function that is defined in one line, that is known as the inline function. So to eliminate the cost of calling to one another, calling to the small function of overheads, C++ proposes a new feature that is known as the inline function. An inline function is a function that is expanded in a line when it is invoked. So what is an inline function? It is a function that is expanded in a line, that is invoked in a line, that is expandable in a line when it is invoked. That is, the compiler replaces the function call with the corresponding function code. Something similar to the macro expansion or macro expression. The inline functions are defined in this way. So whenever I want to elaborate, whenever I want to use the function, whenever I want to expand the function in only one line, that is known as the inline function. So very short functions are known as the inline function. This is inline, then there is a function header, then there is a function body. So inline function, that is a function that is used for the same function that is defined in one line, that is known as the inline function. Inline is a keyword because it is available in dark. So inline is a keyword, then there is a function header, that is a function name, then there is a body of the function, that is the statements that is used in the functions. This is one of the example. This is the inline, then there is a double, cube, double A. Double is the return type of the function and cube is the name of the function. So there is a inline, double, cube, double A. That is the argument, that is the prototype that is used, that defines it contains of data type, or the argument is of double and that have a data type double and that have a variable that is a right. So this is inline, double, cube. So inline function name is cube and the return time is double and the argument that is used is a double A. Then return A into A into A. That means returning the values by multiplying the values, that is A into A into A. The above inline function can be invoked by the statement like this one. If I give c equals to cube 3.0, that is also acceptable. D equals to 2.5 plus 1.5, that is also acceptable. Why it is acceptable? Because this is the value, because these are the value that is available in the double. On the execution of this statement, the value of c and the d will be 27 and the 64. Why? Because 3 is multiplied 3 times. So this is 3 when it is multiplied 3 times, because this is a into a, that is a 27. Then 2.5 plus 1.5, that is a 64. Why? Because first of all it is addition, that is 2.5 plus 1.5 is 4, then 4 into 4 into 4, that is a 64, right? So it is easy to make a function inline. All we need to do is to prefix the keyword inline to the function definition. All inline functions must be defined before they are called. We should exercise care before making a function inline. The speed benefits of inline function diminish as the function grows in size. At some point, the overhead of the function call becomes small compared to the execution of the function. This is the inline function. This is one of the example, that is the inline double cube double a, return a into a into a. Some of the situations, some of the scenarios where inline functions, where inline expression may not work. What are the various conditions? What are the various situations for the function that returning the value? That is, one of the condition is where the inline function may not work. First of all, when the functions where the functions return some values. If a loop, switch or go to exist, or the function that do not return a value if a return statement executes. If a function contains static variable, so if there is any static variable, then also the inline function cannot work. If the inline functions are recursive, that is the next scenario. That is, if the same function is calling the continuously to the 1, that is the same function, means the function is calling the itself, that is known as a recursive function. So if there is any inline function that is recursive, that is not valid, or that is not a valid expression that is used with the inline function. Inline expression makes a program run faster because the overhead of a function call and the return is eliminated. However, it makes the program to take up the more memory, because the statements that defines the inline functions are reproduced at each point where the function is called. So trade-off becomes necessary. This is the example of the inline function. Now let's see. There is a hash include iostream, that means the inclusion of the header file, that is the iostream.h. Then there is a namespace std. Then there is an inline function. So this is a function that is defined in only one line, that is the inline float mul. So this is the keyword, that is the inline. Float is the data type, then mul, that is the name of the function, that is mul. And there are two types of argument that is used. One is a float x, one is a float y. So x and y are two variables that is a float type. So one is float x and one is a float y. And the inline function is used, that is the inline float mul. So mul is the name of the variable, and float is the return type, and inline is the keyword. So mul is a function that is used, and then it is the body of the function, that is a return x and y. That means any values that is multiplied by each other, that is returning the multiply function, that is returning the multiply values. Then next function, inline function, is inline double divide. So double means the return type, and div means that means the return, or that means the function name. And there are two arguments, double p and the q. Then return the p divided by q, that is dividing the two values from one another, that is a p divided by q. Then next is int main, that is the starting of the main, because it is a bottom up approach, so the int main is available at the end of the program. So one is the float a equals to 12.345, that is the a is the name of the variable, b is also name of the variable. A contains the 12.345, b contains the 9.82. So a and b are the two variables that is a float type. A contains 12.345, b contains 9.82. So this is 12.345, This is 9.82. So this is cout, that means displaying the output. One of the function that is used is mul multiply a comma b. So whenever there is a multiply, this is the function declaration. So this is the function declaration, means whenever there is a function declaration, from here the cursor directly moves to this one, because this is the definition of the function. So whenever there is a function declaration, then automatically the cursor moves to the function definition. That is, the function definition is over there. That is a float mul, float x, float y. That means multiplying the two values. Now a and b have the value 12.345 and the 9.82. That is multiplied with each other. That gives the output like this one, 121.228. In the same way, in the next line, the divide function will declare that the divide function will call. So whenever there is a calling of the divide function, whenever there is a usage of the divide function, that is done by the divide, that is div a comma b. So this is div a comma b, that means dividing of the function. So these two values are divided with each other, that is 12.345 and the 9.83. That gives the value as a 1.25713. So this is the function that shows how to use the inline function. Now next is default arguments. That is, the default arguments means using the default values as a parameter that does not match a value specific values. Default values are specified where the function is declared. The compiler looks at the prototype to see how many arguments a function uses and alerts the program for possible default values. This is an example of prototype with the default values. That is, it takes the values default. So this is float amount. That is, the amount is the name of the function. Float is the return type, and there are various arguments like float principal, int period, float rate equals to 0.15. The default value that is specified in a manner semantically or syntactically similar to the variable initialization. The above prototype, this is a prototype, declare a default value of 0.15 to the argument rate. A subsequent function called look like this one, 5007. The 5000 is given to the principal and the 7 is given to the period, and next the function takes the default value, that is 0.15. That means whenever we have to call the function, we have to use only two values for which the default value cannot be defined. And if the any variable has defined the default value, so there is no requirement for giving the argument, for giving the values, right? That is the default arguments. This is the example of the default arguments. Now next is constant argument. That is a constant variable argument that is also used with the constant. This is one of the example that we can pass the argument to a function that can be declared as a constant. This is int strlen constant char pointer p, int length constant string address s. Now the next concept is function overloading. This is one of the important concept that is available in object oriented programming, that is available in C++. This is one of the major major advantageous feature of the C++. So I'm not going to start right now because no time is left for the class. So let's stop over here only. In the next class I will be moving to this topic, that is a function overloading, and please attend tomorrow's class because this is one of the important topic. Okay, so let's stop the session right now and then move to let's stop the class over here. If there is any doubts, any suggestions, any clarity, you can clarify from me. So that's all for today's session. Thank you so much everyone for listening me. If there is any doubts, you can clear the doubts. In the tomorrow's class I will be taking the next topic, that is a function overloading. So thanks a lot everyone. Thanks a lot for listening me. Bye bye.